Hello everyone, welcome to MH Math Academy's KCET Crash Course 2025. In this lecture, we shall take up our second chapter, that is relations and functions. Before this lecture, in the previous two lectures, we have completed the first chapter, that is sets. And since the chapter sets was totally based on the first year PUC portions, I had also taken up the theory part of it. But since the relations and functions is based on your second year PUC portions, and as you have just now completed your boards, I feel it is not really necessary to go through the theory part of the relations and functions. However, while discussing the questions, if I feel any question needs the theory revision, then I will do it then and there. Okay, but otherwise, still I suggest that you go through the theory part of it. If possible, revise the chapter relations and functions once, and then start with this lecture, or you can start solving the MCQs only after the theory revision of the relations and functions. Okay, so in this lecture, what I have done is I have taken up the KCET previous year questions, which have appeared after 2020, I suppose. Okay, so without any further delay, let us now begin with the first question. What does the first question say? The first question says, let R be a relation defined in N. What is N? I had told you while revising the chapter sets, N is the set of natural numbers. Okay, they usually give it as just N, but in our lectures, we'll denote it by slash n. Okay, as A R B, what do you mean by A R B? It means A is related to B under the relation R. Okay, if 3a plus 2b is equal to 27, so a is related to b only when this equation is satisfied. Okay, that is what they have given. Then R is, so we have to find out R. So what I'll do is I'll take this equation first. The equation that is given is 3a plus 2b is equal to 7, sorry, 27. And since the relation is defined in N, both a and b must be the natural numbers. Okay, so what I shall do is I will keep substituting the natural numbers for a, and I will find out the values of b, and we'll see whether all those values are going to be in N or not, and then we'll decide what is going to be the relation. So since I have to find out the value of b, what I will do is I will keep 2b here and take 3a to the other side. I'll get 227 minus 3a. So this implies b is going to be 27 minus 3a divided by 2. So this is what is going to be the b. Now, since a and b both belong to natural numbers, I'll start substituting the natural numbers in the place of a. If I take a equal to 1, I'll get b equal to what? 27 minus 3 ones are 3 divided by 2, which is 24 by 2, which is equal to what? 12, which is a natural number. So therefore, I can say that the number 1 is related to the number 12. So this implies 1 comma 12 belongs to R. So this is the first element that I found out, 1 comma 12. A is equal to, if I put 2, B will be equal to what? 27 minus 3 twos are, it is going to be 6 divided by 2. 27 minus 6 is 21 by 2, which is 10.5, right? Which is 10, but not a natural number. So therefore, A is in N, but B is not in N. So this ordered pair is not going to appear. If I take up the next one, if I put a equal to 3, I'll get b equal to what? 27 minus 3 threes are 9, right? So it is 9 divided by 2, which is going to be 27 minus 9. It is going to be 18 by 2, which is 9, which belongs to n. So therefore, I can say that 3 comma 9 belongs to R. A is 3, B is 9, belongs to R. At this point, if I check, you can see 1 comma 12, 3 comma 9 is what I have got. 1 comma 12 and then 3 comma 9. We'll see if is this the only relation that has it. 1 comma 12, 3 comma 9. Yes, 1 comma 12, 3 comma 9, but there are others also. As you can see, this and this are almost similar except one ordered pair. Let's see. Now what I'll do is I will substitute a equal to possibly after 3 I have to substitute 4. But see, if I substitute 4 here, what is going to happen? 3 fours are 12. Okay, 27 is an odd number and 12 is an even number. So odd minus even is going to be odd. So odd by 2 is never a natural number. So it is of no use substituting the even numbers here. So what I'll do is I'll just keep taking the odd numbers. I'll take a equal to 5. What will I get? B equal to 27 minus 15 divided by 2, which is going to be, I think, 27 minus 15 is 12. 12 by 2 is 6 belonging to n. So it is 5 comma 6 belonging to r. So the next ordered pair is 5 comma 6. Again, in both of these it is there. And then again I'll skip 6. I'll take 7. B equal to 27 minus 3 sevens are 21 divided by 2, which is going 27 minus 21 is 6 by 2, which is 3 belonging to n. So therefore it is 7 comma 3. In both of these it is there. And if I I have to decide whether it is option A or option C now. Okay, because these two are ruled out. 0 comma 27 by 2 is not there because 0 is not a natural number, and these are also absolutely not there. But now I have to check for A equal to 9. If I put A equal to 9, what is going to happen? B is equal to 27 minus 3 nines are again 27 divided by 2, which is going to be 0, which is not a natural number as per the textbook. So therefore, of course, these three are wrong and option 1 is obviously right. So these three are wrong, option 1 is obviously right. Fine. So this is how we can uh, find out the relation using the rule that is given. Okay, such question can be asked because there are too many questions like this in the textbook, so it is better that you practice these questions once. Okay, once doing this, we'll go to the second question without any further delay. The second question says, if n of a is equal to 2, what do you mean by n of a equal to 2? A has two elements and the total number of possible relations from set A to set B is 1024, then n of B is. Okay. So, uh, what is the concept here? Okay, the concept is if A has m elements and B has n elements, then A cross B will have m cross n elements, that is m into n elements. Okay, what is the relation from A to B? The relation from A to B is a subset of A cross B. It is a subset of what? A cross B. So in order to count the relations from A to B, it is better that I count the number of subsets of A cross B. So A cross B has how many elements? 2 raised to mn elements. So therefore, the number of subsets of A cross B are going to be 2 raised to mn. So therefore, what I can say is if A has m elements and B has n elements, then the total number of relations from A to B are going to be 2 raised to mn. Okay, so this is what I have. In this case, it is given that A has how many elements? 2 elements, and B has how many elements? I think that is what we have to find. I'll call it as x. Okay, then and they have given that the total number of relations from A to B is 1024. What are the total number of relations here? 2 raised to 2x, okay, is going to be 1024. This is what they have given, right? So therefore, what I can write down is 2 raised to 2x equal to, can I write this 1024 as 2 raised to 10? Yes. So therefore, comparing these two bases are same, so the powers also must be same. Therefore 2x will be 10, therefore x is going to be 5. So therefore, what is x? X is the number of elements of B, so therefore n of B is going to be 5. So it is going to be the option B. Okay, that was a very simple problem that we had. Fine. Coming to the question number 3, what does the question number 3 says? If A and B are non-single sets, what do you mean it's not non-single? I can just say it is non-singleton sets. Non-singleton. So what do you mean by non-singleton sets? Both of them do not have one element. Okay, so that is what it says. And n of a cross b is equal to 35. So n of, just a minute, n of a cross b is equal to 35. Okay, this is what is given, and we have to find this one. So before beginning with that, why did they give that these two are non-singleton sets? I'll tell you why. Okay, see, n of a cross b is equal to how much? 35, right? So if I have to factorize 35, see, I had told you earlier, if a has m elements, b has n elements, then a cross b will have m into n elements, right? So a cross b has how many elements? 35 elements. So a can have one element and b can have 35 elements here, right? 1 into 35, or it can be 35 into 1. The other possibility is 7 into 5 and then 5 into 7. So these are the only possibilities. Since here A has one element or here B has one element, they are saying that these two are non-singleton sets. So these two are ruled out. These two are ruled out. So now the only possibility is A and B. Either A can have 7, B can have 5, and A can have, or A can have 5 and B can have 7. So this is the only possibility that I have. Now after this, they have given B is a subset of A. What do you mean by B is a subset of A? The number of elements of B are either equal to that of A, or the number of elements of B are lesser. So since the number of elements of B are lesser, I can say that B has 5 elements and A has 7 elements. So therefore what I can say is n of A is equal to 7 and n of B is equal to 5. So this is what I have. Therefore n of A C n of B is equal to, what is n of A? It is 7 C5. What is 7 C5? 7 C5 is equal to 7 C2, right? I hope you know these calculations. Otherwise, we'll revise it in permutations and combinations. So 7 C5 is 7 C2, which is 7 into 6 by 2 into 1. 2 ones are 2 threes are, so it is going to be 21. So therefore, it is option D, that is option 4. Okay, so it has n of A, C, n of B is going to be 21. Okay, fine. So let us now take up the fourth question, which is again, I think, on the very similar concept. Suppose that the number of elements of set A is P. Okay, so set A is there, the number of elements, that is n of A is equal to P, and the number of elements of set B, okay, n of B is equal to Q, and the number of elements of A cross B is 7. Okay, n of A cross B is equal to 7. Then they are asking the value of P square plus Q square is equal to dash. Fine, we can do it. It's not a big deal. Now look, A cross B has how many elements? 7 elements, right? So as I said, if A has m elements, B has n elements, then the total number of elements are going to be m into n. Here A has how many elements? P elements, which is already given, and B has how many elements? Q elements, which is already given. So P cross Q is equal to how much? 7. So if I have to factorize it, what am I going to get? 1 into 7 equal to 7, or 7 into 1 is equal to 7. This is the only possibility. So either 1 comma 7 must be there, or 7 comma 1 must be there. That means if A has one element, B will have 7 element, or if A has 7 elements, then B will have 1 element. So out of these two, there is only one possibility that can occur. Now, doesn't matter which one of these take 1 or 7, this will be remaining the same, because at the end it is going to be 1 square plus 7 square or 7 square plus 1 square. The value is going to remain the same. So I will just take up this one, the first one, that is 1 square plus 7 square, which is going to be 1 plus 7 square is 7 square is 49, which is going to be 50. So therefore the answer for the fourth one is going to be option A, that is 50. Okay, coming to the next question, which was asked in 2020, it says if a relation R on the set, okay, 1 2 3, we defined by R is equal to 1 1, then R is, that is what they are asking. Okay, The first option says reflexive and symmetric. The second option says reflexive and transitive. The third one says symmetric and transitive. The fourth one says only symmetric. Now, if you go back to the definitions of reflexive, symmetric, and transitive relations. What does the reflexive relation says? A relation is said to be reflexive if every element of A is related to itself. What do you mean by? See here in this case, the set A. If I want, I can take it as set A. It has three elements: one, two, three. So this relation, if it is defined in A, is set. I mean, if we want to call it reflexive, one should be related to one, two should be related to two, three should be related to three. I hope you are getting it. So if 1, 1, 2, 2, 3, 3, all these three are in the relation R, then it is going to be reflexive, otherwise it is not reflexive. So therefore, this first one and second one are already wrong, because it says it is reflexive and something else. Can be something else, but we are not sure whether it is reflexive or, I mean, we are 100% sure it cannot be reflexive. Now, is it symmetric? Is it symmetric? Then for this, what I shall do is I will, take you back to the definition of symmetric relation. What does the symmetric relation says? The symmetric relation says if A is related to B, that is A comma B belongs to R, then B comma A must also be in R. Okay, then R is said to be what? A symmetric relation. Now here you can see only one is there in R. So the reverse of this, or the symmetric, the if I reverse the position of 1 and 1, again I'm going to get 1 and 1. So if I call this as A and this as B, so this is all, I can call this as BA. So AB is there, BA is also there. So therefore it is going to be symmetric relation. And what about the transitive relation? The transitive relation says, just a minute, before going to the transitive relations, what if there is no element like AB? Then do we have to search for BA? No, there is no need of searching for BA. If AB itself is not there, then by default it is symmetric. Then by default it is what? Symmetric. For example, if I give you the relation, let's say R is equal to the empty relation. Is it reflexive? No. Why is it not reflexive? Because 1, 1, 2, 2, 3, 3, none of them are in R. So therefore it is not reflexive. But is it symmetric? Yes, it is symmetric. Why is it symmetric? What does the symmetric condition say? If AB, then search for BA. If there is no AB at all, then by default it is going to be symmetric. You cannot say it is not symmetric. Okay, I hope my point is very clear. If you have AB, then you have to find BA. Okay, if there is AB and if there is no BA, then it is not symmetric. Okay, if there is AB, I mean if there is no AB at all, then by default it is going to be symmetric. We need not have to worry about the presence of BA here. Okay, and the third condition is, I mean the third definition, that is the transitive relation. A relation is said to be transitive if AB is in R and BC is in R, then AC must also be in R. That is what it says. Okay, and see, if there is an ordered pair AB in R and there is another ordered pair which is starting with B, then AC must also be in R. Okay, for this I need to have minimum of how many ordered pairs? 2 ordered pairs, but here there is only one ordered pair. So there is no question of checking for transitivity. Again, it is by default true. So why is it by default true? It is by default true because AB is there, BC is not there, then it is still transitive. If AB and BC are also not there, I mean both of these are not there, again if I take up the empty relation, there is no AB, there is no BC, there is nothing, so therefore it is transitive. Okay, when is it not going to be transitive? If AB and BC both are there and AC is not there, then only it is going to be not transitive. Okay, I hope what I am saying is clear. So therefore this relation, what they have given, that is 1 comma 1, is not reflexive, but it is symmetric and transitive. So therefore it is our option 3. So option 3 is the correct answer. Okay, fine. So let us now go to the next question. That is, if f from R to R defined by, what is R here? R is the set of all real numbers. Okay, don't get confused. If f is a function defined from R to R, which is given by f of x equal to so and so, then f of minus 2, f of 3 plus f of 4 is okay, fine. So what they have given is, just tell you, let us say this is the real line, okay, the domain of f from minus infinity to plus infinity. X is split at 3 points, 2 points. One is 3 and the other one is 1, right? So let us say there is 1 here and there is 3 here. Here you can see x is less than 1, here x is equal to 1, here x is greater than 1 and less than 3, here x is equal to 3 and here x is greater than 3. Okay, so this is what we have. Now what does it say? When x is greater than 3, the function is 2x. When x is at 3, if you can see here, when x is at 3, that is equal to 3, the function is x square. So here the function is going to be x square, and between 1 and 3 in this place again the function is x square. At 1 and when x is less than 1, in both the cases the function is 3x and 3x. So now they are saying the value of the function at x equal to minus 2, x equal to 3 and x equal to 4. Okay, so where is minus 2 here? The minus 2 appears here, right? The minus 2 appears here, and 3 3 is here, okay, and then 4 appears here, right? 4 appears here. So therefore uh, for this case, okay, f of x is going to be 3x. So therefore what is f of minus 2 here? F of minus 2 is 3 times minus 2, which is minus 6. Okay, in this case, that is at x equal to 3, f of x is going to be what? X square. So therefore f of 3 is going to be what? 3 square, which is 9. Okay, and for this case, if you see, f of x is going to be what? 2x, right? So therefore if I substitute x equal to 4, it is going to be 2 into 4, which is going to be 8. So now if I have to add these, that is f of minus 2 plus f of 3 plus f of 4, this is going to be minus 6 plus 9 plus 8. Okay, so 9 minus 6 is 3, 3 plus 8 is 11. So the answer is going to be 11. It is option 4. Okay, so this is what we have. And you can see, I think this is the very similar question. See, there is this question which is given in 2021, the same is given in 2022, but here they have asked f of 1, f of 3 and f of 4. F of 1, f of 3 and f of 4. Okay, fine. See, yeah, I'll just check whether it is 2x, x square and 3x, x greater than 3. Yes, it is the same question. It is the same question. So f of 1 plus f of 3 plus f of 4 is all we need, right? So it is going to be equal to what is f of 1? Just a minute. What is f of 1? At 1 the function is 3x, so it is 3 ones are 3, so it is going to be 3 plus what is f of 3? At 3 the function is x square, so f of 3 was already found out, it is 9 plus what is f of 4? F of 4 is 8. Okay, so 9 plus 3 is 12 plus 8 is 20, but it is not there. Okay, what is f of 1 again? At 1 the function is 3x. Okay, at 1 the function is 3x, so 3 into 1 is 3, fine. At 3, just a minute, at 3 uh, the function is x square, so 3 square is going to be 9, absolutely fine. At 4 the function is 2x, it is 8, 9 plus 3 is 12, 12 plus 8 is 20. I think there is some issue with the answers here. So we will just change one of the options. I think it must be, I'll just strike this off and write the fourth option to be 20. So the answer is 20. Of course, the answer has to be 20. Okay, fine. So let us now go to the next question without any delay. Okay, the next question says the domain of the function f of x equal to 1 by log of 1 minus x plus root of x plus 2. Okay, so to find the domain, we have very two simple rules, or let's say the three simple rules. The first one is the function must be defined. Okay, function must be defined for all the values of x that we are going to substitute. Okay, so for the function to be defined, okay, we will get only two cases in this, I mean, entire chapter. The first one is the denominator should not be equal to 0, and under the square root we should get only the positive numbers. There should not be any negative numbers. Okay, and even we can get 0 under the root, but we cannot get any negative numbers. So these are the only two conditions that we have. Okay, if there is a logarithm, the third condition, if there is a logarithm, then under the logarithm I should get only the positive numbers, not even zeros or negative numbers. Okay, so in this case the function what they have given, okay, if I take up the function f of x is equal to, okay, 1 by log of 1 minus x plus root of x plus 2. This is what they have given. Okay, for this one to be defined, just let me be clear, for this one to be defined, the denominator should not be equal to 0, first case. So log of 1 minus x should not be equal to 0. When will be log 0? When this is equal to 1, right? So log 1 is 0, so this cannot be 1. So 1 minus x cannot be equal to 1. So this implies x cannot be equal to 0. So x cannot be 0. That is the first condition that I got. The second condition is inside the logarithm I should get only the positive numbers, right? So 1 minus x has to be positive. This implies 1 greater than x, so therefore x must be less than 1. So this is the second condition that I got. So x must be strictly less than 1. And the third condition that I am going to get is from this. See, x plus the root of x plus 2 is in the numerator, so there is no question or there is no issue if it becomes 0. But this x plus 2 within the square root has to be positive, right? So therefore x plus 2 has to be greater than or equal to 0. So therefore x has to be greater than or equal to what? Minus 2. So these are the conditions that I have. If I have to find out all these things, what I'll do is I will better just a minute, I will draw a number line. Okay, so let us say this is minus 2, this is 0, and this is 1. Okay, x has to be less than 1, that means it can take all these values except 1. 1 cannot be included, and x cannot be 0. Okay, x cannot be 0, and x has to be greater than minus 2. So x has to be greater than minus 2. So see, for this function to be defined, that is for f of x to be defined, I need this and this part of the function both to be defined, and both of those have to be defined. So both are defined only in which region? You can see both are defined only in this particular region except 0, right? Except 0. So what I can say? I can say that the domain now is including minus 2, right? So from minus 2 to 0, but I cannot include 0, union 0 to 1, I cannot include 1 also because x is strictly less than 1. So it is closed minus 2 to open 0, union open 0 to open 1. So it is going to be the option 4. Okay, this is going to be the right answer. Fine. I think here they have given, no, it is the intersection. No, it is not the intersection. It is not the common region, because the common region is going to be what? The common region is going to be a null set, because both of these have no common points, right? It is ending at 0 and it is starting at 0. 0 is excluded. So therefore it is an empty set. Okay, it looks like the same answer, but it is an empty set. So 1 is not the correct answer. It is going to be 4. Okay, fine. Coming to the next question. The next question says the domain of the function. Okay, the domain of the function f of x is equal to so and so. Okay, now again, to find out the domain of a function, I have only two criteria. The first criteria is the denominator should not be 0, and within the root I need to have the positive number. Now look, this square root in the f of x is in the denominator. So therefore, the first point that I have to make is this root whatever we have should not be 0, because it is in the denominator. And here I need to have positive quantity. I mean, can be equal to 0, but since it is in the denominator, it should not be equal to 0. So it cannot be greater than or equal to, it should be strictly greater than 0. I hope you are understanding. See, what do I mean to say here is, if the square root is in the numerator, then I can have 0. But since the square root is in the denominator, I cannot have 0. And within the square root, I should have only the positive numbers, not even equal to 0. So therefore, now the condition for to find the domain here is this box x square minus box x minus 6 should be strictly greater than 0. So this is what we have. Okay, so to find out the exact points at which it becomes 0 and all, so what I'll do is I will equate this to 0. Box x whole square minus x minus 6 equal to 0. If I make it equal to 0, what do I get? I'll get box x whole square. Can I write it as, by for factorization, 3 box x plus 2 box x minus 6 equal to 0, right? So this is going to be what? If I take out box x, it is going to be box x minus 3 plus 2 times box x minus 3 again equal to 0. So therefore it is going to be box x minus 3 as the first factor, and then box x plus 2 as the second factor, which is equal to 0. So therefore this becomes 0 at 3 and at minus 2. So x box x cannot be equal to 3, because it should not be equal to that we will decide later. Okay, that we will decide later. Now, when will this be positive? When will this be positive? So for that, what I'll do is I will draw a number line. Okay, I will draw a number line. I have got two roots here. One is box x equal to 3, and the other one is box x equal to minus 2. So let us say this is minus 2 and this is 3. Okay, this is from minus infinity to infinity. At minus 2 and minus 3, it becomes 0. So therefore I cannot include both minus 2 and minus 3. So I'll create a hole at minus 2 and I create a hole at 3, because at minus 2 and minus 3 the denominator is going to be 0. Okay, so I will put a hole there, and now this has to be positive. This has to be positive, right? So what is this? This is going to be this factor, right? I have factorized this one only, right? So it is box x minus 3, box x plus 2. That is what we have. Now when x is less than minus 2, okay, of course this is also negative, right? When x is less than minus 2, this is also negative, right? So negative into negative is going to be what? Positive. So here it is positive, of course. Here it is positive. Now when x is greater than minus 2, and in this region, when x is greater than minus 2, this is going to be positive, but this is still going to be negative. So minus into plus is going to be minus, so here it is going to be negative. And after 3, of course, this is also positive and this is also positive, so it is positive. So therefore in this interval and in this interval it is positive. So therefore the interval is going to be minus infinity to minus 2 open, union 3 to infinity open. So this is what I have, and at 3 here they have given the closed bracket. If I put 3, it is going to be 3 square 9 minus 3, 6 minus 6, 0. So it is going to be 0. So I don't want it to be 0. So therefore it has to be the open interval at 3. It cannot be the closed interval at 3. So we'll change it. Okay. So I'll better change this to the open interval, one of the options. I think I will change this one only. It's going to be the open interval. Okay. So let us now go to the next question. Okay, the next question says, if the set X contains 7 and set Y contains 8 elements, then the number of bijections from X to Y is. Okay, so what is a bijective function and what are bijections from X to Y? I will just explain it to you. Okay, suppose that you have a set X and set Y. When do you say that, there is a bijection from set X to set Y? Let us say, there are 3 elements here, 3 elements there. It's a 4 elements here. If all the elements of X have an image in Y and a unique image in Y, okay, all the elements of X must have a unique image in Y, and all the elements have Y, all the elements of Y must have a unique pre-image in X. So what do I mean to say is, if I take an element here, it should have a unique image in Y. If I take an element here, it should have a unique pre-image in X. So therefore all the elements of X have a image in Y and it is unique. All the elements of Y have a pre-image in X and it is unique. So therefore the number of elements of X must be equal to the number of elements of Y. So therefore n of X must be equal to what? N of Y. But in this case, set X contains 7 elements and set Y contains what? 8 elements. So therefore there cannot be any bijections from the set X to set Y in this case. So therefore it is going to be the option A, that is 0 bijections. There cannot be any bijections at all. Okay. So coming to the next question, that is f from R to R defined and g from so and so to R are defined by, there are two functions that are given, f of x is equal to x square and g of x is equal to root x. Okay, then which of the following is not true? Okay, let's be very careful here. They are saying which of the following is not true. Okay, so what I'll do, and if I look at the options, it is f of g, g of f, g of f, f of g. So first I'll find out g of f and f of g, and then we'll see what can be done. Okay, so what is going to be f of g of x? F of g of x is going to be f of g of x is root x, which is equal to f of x is what? X square. So it is root x whole square, which is equal to x. So therefore f of, just a minute, okay, f of g of x is going to be x. This is the first thing that I found. And what is g of x? Sorry, g of f of x is equal to, what is g of f of x? It is g of, what is f of x? F of x is x square. So it is root of x square, which is x. Okay, because x is anyways, since we are substituting it in g, it has to be positive. So let us make it positive. So therefore g of f of x is equal to x. Okay, now you can see the first option says f of g of 2 equal to 2. So if I put 2, it is also going to be 2. So therefore f of g of 2 equal to 2. It is true. It is true. Okay, g of f of 4 is 4. G of f of 4 is 4. Yes, this is also true. Next, g of f of minus 2 is 2. If I put minus 2 here, it cannot be 2 here. As you can see, it cannot be 2 here. So therefore this is something that I but one thing that I can make out, just give me a moment. F of g of minus 4 is 4. What do you mean by f of g of minus 4? If I put minus 4 here, it is going to be 4. Okay, but if while taking the square root I made a mistake here, while taking the square root I can say it is plus or minus, right? So therefore what I can say is when I put x equal to minus 2 here, it can be 2 also. So therefore this is true, this is true, but this is false. So therefore option 4, that is f of g of minus 4 is equal to 4, is going to be the correct answer. Okay, so this is what we have. Now let us go to the next question, that is let f be a function from R to R defined by f of x equal to 3x square minus 5 and g of x equal to so and so, then g of f is, okay, so g of f of x is going to be g of f of x. What is f of x? 3x square minus 5, right? So this is equal to, what is g of x? It is x by so and so. So wherever there is x, I am going to substitute 3x square minus 5. So it is 3x square minus 5 divided by x. In the place of x, I have to substitute 3x square minus 5 again, the whole square plus 1. Okay, so if I expand it, what will I get? It is 3x square minus 5 divided by, it is going to be a square plus b square minus 2ab. So it is a square, okay, plus b square, I will write down later, minus 2ab. What is going to be minus 2ab? Minus 2 3s are, it is going to be 6, 6 5s are 30, minus 2ab, okay, plus b square is 25 plus 1 is going to be 26. So it is 9x raised to 4 minus 30x square plus 26. Okay, again here there is a mistake, it is, it should be minus 30x square. Okay, 9x raised to 4 minus 30x square plus 26, and here it is, so it must be option B. Okay, coming to the next question, I think this is the last question that we have for this lecture. It says if f of x is equal to ax plus b, and f of minus 1 equal to minus 5 and f of 3 equal to 3, then a and b are respectively. Okay, so we'll first take up f of x equal to what? Ax plus b, right? Now it is given that f of minus 1 is equal to what? F of minus 1 is equal to minus 5. So if I put x equal to minus 1 here, I am going to get a into minus 1 plus b. What is f of minus 1? It is minus 5 equal to minus a plus b, right? In the second one, f of 3 is equal to what? It is 3a plus b, right? What is f of 3? F of 3 is 3, which is equal to 3a plus b. Fine. So if I have to solve these two equations, what I'll do is I will just bring it here. 3 equal to 3a plus b. So I will better subtract these two. B and b will get cancelled out. Okay, so minus a minus 3a is minus 4a equal to minus 8. Okay, minus and minus will get cancelled out, so a is going to be equal to 2. A is 2. So this and this, out of these, one of these is the answer. So what I'll do is I'll put a equal to 2 here. I'll get 3 equal to 3 2 plus b. So it is 6. If I send it to the other side, it is going to be minus 6 plus 3 is equal to b. So b is equal to minus 3. So it must be the option D. Okay. So this is all about the chapters relations and functions. We have solved around 13 questions. Yes, there were a few confusions in the uh, options of a few questions. I am really sorry about it. I did not observe it before the lecture. But other than that, I think what we have done is absolutely fine. There were absolutely no errors at all. Okay, so in the next lecture, what we shall do is we shall take up the trigonometric functions. But again, before coming to the next lecture, I request that you revise relations and functions once again. You solve a few more problems, and then you revise trigonometric functions and inverse trigonometric functions also. Okay, so let us meet in the next lecture tomorrow.